Hi there, this is JNAL Algebra Lessons, and this is Unit 5, and this is a video on how to graph rational functions. So, we've learned different things in the last lessons, and now it's time to see how this actually looks on a graph, and how to graph it. So, there are 5 steps that are noted by all things algebra, so I'll use these 5 steps that they say, and I'm going to write them down. Simplify, and that would mean by factoring. So once you see what you're supposed to graph, simplify it to factor, because that can make things cancel out, so that matters. Then you need to find the following. Well, they actually use that in 4 steps, so this is really just the second step, but there's multiple parts to it, so I'm just doing 2 steps. You need to find the x-intercept, and I'm just going to do this because as we look at examples, we'll see what it would look like. You can find the y-intercept, but that's not a necessary thing. You need to find the vertical asymptote, if there is any. You need to find the horizontal asymptote, if there is any. And then find holes. We already talked about that or discontinuities. Well, and also you might be able to find a slant asymptote, but I'm not going to put that on there because that's not a typical thing always. That's only if there happened to be a situation once you start graphing that, it was different. Oh, well, you also, it's important to know your domain and range. Okay, so let's see, how do we do this? Oops. Okay, how do we do this? I'll just draw a little graph here. I could have pulled up the thing that I've used before, but I didn't feel like doing it. So here's an example. Graph y equals 2x minus 6 divided by x minus 1. So in the last, 3 or 4 videos, I've taught you how to find all these things that are listed here. Well, not domain and range, because you can find that using what you're given, but really, it's easier to know after you start graphing. So, we already said that when you're trying to figure out what the x-intercept is, you need to set the numerator equal to 0. But in this case, we would want to simplify first, and we can simplify by factoring out a 2 to get x minus 3 here, because we can see that would multiply to equal 2x minus 6, and then you can't factor x minus 1, so we'll leave that as it is. But it didn't really matter, because the only reason why they tell you to simplify is in case there is something that can cancel out, and if there is something that cancels out, there's a hole. But since nothing canceled out, we already can fill this in and say no holes on this one. So we set the numerator equal to 0. We can pretty much just do this. We don't really need to use this one and set that equal to 0. We can just do the unsimplified one. So then you would get 2x equals 6, and then x equals 3. So there is x-intercept, and it's 3. So 3. 3, 0 is our x-intercept. Let's go ahead and plot that. So let's say that's right there. I'm not going to write the number just for this purpose, but that's our x-intercept. Okay, vertical asymptote. To do that, we set the denominator equal to 0. So x minus 1 equals 0. X equals 1. That is our vertical asymptote at x equals 1. So x equals 1 is right here. Okay, there we go. Horizontal asymptote. We find that by looking at the powers, depending on if one is greater than the other or if they're equal. Since they're equal, you simplify the coefficients by dividing them. So there's a coefficient of 2 here and a coefficient of 1 since there's nothing there. So 2 divided by 1 is 2. So the horizontal asymptote is at y equals 2. So that would be right here. And when you're doing when you're doing slant or horizontal asymptotes, you don't fill in the middle. The reason why is sometimes the line will have to go through that, because remember, the asymptotes are where the line's not supposed to go through, but it may be impossible for that to occur. So now we've done everything we can, and now we need to start drawing the line. Okay, so what do we do to start? Well, here's a major tip. If the leading coefficients are positive, then the graph will start by being above the x-axis, and it will be above the x-axis, and it will be pointing to the left. So pretty much it's going to be in this quadrant, the positive quadrant. So that usually you do have positive coefficients. So usually you'll start out like right here. But here's what you have to do when you're graphing. When you're graphing, I'll just write tips here. It needs to go through all points. I'll say PTS, and it also needs to never go through asymptotes. Okay, so that's kind of messy, but I said that it needs to be above the x-axis, but in this case, that contradicts that rule, because we see it needs to go through all points, and that one is not, it's on the x-axis. So we start by going to the left. Remember, you always go to the left if it's positive, and start over here. It goes through that. It keeps going, but then it's like, oh, it sees that, and then it knows that it's not going to be able, it has to go down. It can't go up because there's another asymptote right there. So it's like, okay, fine, I'll go down, because it can never touch them. It can never go through them. Okay, so we're drawing it, and it kind of, it doesn't bend. It's kind of like a curved corner. Now it's off the graph. So now what do? You have to make it skip across the vertical asymptote, but it has to be going the same direction that it was going. What direction was it going when it went off the graph? It was going down, so it still wants to go down. So you can't do this. That's not what you do. You have to make it go down, so it will start up here now, because it still has to go down. It just was able to skip across that vertical asymptote. Now it keeps going down, and in this case we can draw the thing across the asymptote, and we see that it's like, oh, there's another one. I'll just curve this way. So that is what the graph would look like. It's not exact, but that's basically what it would look like. Now we need to do the domain and range. But as a review, you always need to go through all points. Don't go through the dotted lines, asymptotes. And when you go off the graph, you need to start, once you skip across the line, you need to keep going the way that you were going, which was down. Even though I drew an arrow pointing up, that's just because you draw arrows at the end. So domain. Let's see. Okay, so we can see that it goes all the way to negative infinity. So we'll start out by doing that. I'll just draw these longer because they're usually longer. So negative infinity. Okay, and then how far does it go? Oh, it stops here because it can't go through that. So that's at 1 because there's an asymptote there. So we say that. It's not including it, so no bracket. And we need to draw the U, meaning and, because that's also, we also have another part. And then it picks up after the 1, once again in parentheses, and then it goes all the way to infinity. So that's the domain. So basically the domain, if there's no asymptotes, it can be all real numbers. But if there is asymptote, then it stops wherever it is, and then it picks up after. Same thing with range. And And if there's a hole, that affects the domain and range, but there wasn't one in this example. So once again, the range starts at negative infinity and it goes all the way to here. It stops there, which is 2. Picks up at 2 and then goes to infinity. So that is the domain and range. So that's how that would be that one. Let's look at one more example where we have a hole. Okay, let me erase all the things that I wrote. And I'll just redraw this. Okay, so let me fix some things here. Draw this back. Okay, our next example is y equals x plus 5 divided by x squared plus 9x plus 20. First step is to simplify. Let's factor this. We can't do anything with the numerator, so let's factor the denominator. We would see, once again, I'm not going through this because we already learned that, but you would get x plus 4 and x plus 5, so when doing the product sum method. Okay, so, and going back to our first lesson of this unit, we see that these things would cancel out, wouldn't they? So once you cancel them out, you would just end up with 1 up here over x plus 4. So that is our simplified. Oh wait, yeah, I thought I did something wrong for a second. Okay, so that is our simplified answer. But we notice we already need to say, since something cancel out, we have a hole, remember? So we set x plus 5 equal to 0 to find the x value, which is negative 5. So that's the x value of the hole, because remember, the hole is at a certain point. So we have negative 5, and to find the other coordinate, the y coordinate, you plug that in as x. Wait a second. Oh, sorry. Once again, I thought I messed something up, but I didn't. Okay, so you have 1 over negative 1, which is negative 1. So that means that the y would be negative 1. So let's plot that point. Let's say it's right there. So that's our hole. Okay, if we have a hole, then we know that some things won't apply. So is there an x-intercept? No, because we canceled out the x plus 5. Now we just have a 1. You can't find out what x is. So no x-intercept this time. Okay, for the vertical asymptote, we do have something that would work. So x plus 4, set that equal to 0. You get negative 4. So that's our vertical asymptote. Horizontal, look at the degrees. We see that the degree is greater. It is greater on the denominator, so that means that it's 0. Remember? 0. Okay, so now we can plot. Let's go ahead and draw our asymptotes. So we have x is negative 4. X equals negative 4, so oh, don't know what happened there. Okay, and then we have y equals 0, so that's just going to be here on this axis. Okay, so remember, since they're still positive here, so we start out above the x-axis over here. Remember, for the last one, we didn't start above the x-axis just because we had to go through the point, because we have to go through points, but since there's no points, we can. And it starts out by going to the left, so it's going to keep being close to the asymptote or the axis. Then it sees that, so it's like, okay, I have to go this way. That's supposed to be more curved, sorry. So that's our first part. Since it was going up, it needs to stay going up. So it will go here, but it needs to go through the asymptote. So it must go through all points. Or sorry, the whole. And then it needs to curve right here because it doesn't want to go through the asymptotes. And then that's it. Okay, so now we can do a domain and range. For the domain, we see that it goes to negative infinity, and then this doesn't apply. The whole doesn't apply, and the x value for the whole was -5. So it stops there, picks up at -5, but then it has to stop again at that asymptote, which is -4. So we do that. Then it can finally pick up again at -4, and then luckily it can go all the way to infinity. Okay, then we have the range. Once again, it starts at negative infinity. Oh, has to stop at the whole. Y value is -1. Then it has to stop again at the 0, the x-axis. So then we do -1 to 0. Then it finally can go all the way to infinity. And that would be our answer. So that is how you graph rational functions. It's not as set and dry as the other ones, but you basically just need to follow these rules and these steps. So thanks for watching, and I'll see you on the next video, which will be a test review. Thanks for watching.